Namaskar, Nileshok here, and welcome back to the course on Introduction to Indian Calendar. In this module, we are going to look at some of the implications of these positions of the Earth or the Sun as seen from the Earth with respect to the position of the Earth called perihelion, which is when the Earth is closest to the Sun, or Aphelion, when the position of the Earth is farthest from the Sun. And in a similar fashion, the position of the Moon with respect to the Earth, when it is closest to the Earth, the position is called perigee, or farthest from the Earth, the position is called apogee. They are also known in the Indian calendar system as mandocha or shigrocha, shigra meaning fast, mandocha meaning slow. So for example, at Aphelion or at apogee, the speed, the angular speed of the Sun or the Moon as seen from the Earth is felt to be the slowest, more like a mandocha. And at the perihelion or at perigee, the angular speed of the Sun or the Moon as seen from the Earth is felt to be the fastest, like a shigra or shigrocha. That is, the point will be shigrocha. Now, what we are going to do in this module is to look at in a model where Sun is at the center. In fact, we will not show the Moon, and Earth is going around the Sun. We are going to add the two foci of the Sun that we discussed last time. Okay, these are the so-called center points of an ellipse or elliptical path. Okay, they appear off center just like the Sun or the Earth appears in this picture. Okay, off center with respect to that circle, elongated circle. And we will also impose or superimpose the background nakshatra system and see what are some of the implications of this off-center position of the bigger inertial body, either the Sun in case of Sun and the Earth, and the Earth in case of the system of Earth and the Moon together. And what are its implications, at least some of the implications for the Indian lunisolar calendar. What we are showing is the scenario that is valid in our times, 21st century. Do notice the change from some of the previous modules. In this demonstration simulator, we are showing the position of the Sun at the center as opposed to Earth being at the center. I will repeat, if one wants to study Indian astronomy, any astronomy for that matter, but especially Indian astronomy in the context of Indian lunisolar calendar, then it is a must that the person is very comfortable in switching the position of the Earth at the center to the position of the Sun at the center. And we are doing this deliberately because that is the way some of these intricate aspects of the astronomy and its implications on Indian lunisolar calendar can be understood. Remember, we discussed that the actual path of the Earth around the Sun is not perfectly circular. Rather, it is elliptical. And whereas the circle has one center. In the case of ellipse, it has two foci, and the bigger inertial body, in this case, the sun, is at one of the foci. That's called focus. Okay, so individual is a focus. So that sun position is, let's think of this as being at F1, focus 1. And if you notice, there is just some distance. It's not a huge difference. There is that another focus, F2. So it's not at the center of the circle because it is not a circle. It is an ellipse, but with a relatively small eccentricity, and still it has huge implications for astronomy and definitely for Indian lunisolar calendar. So this is, that first yellow dot is our sun. The other one is the other focus of the ellipse. Although this is drawn as a circle, imagine that it's not exactly circle, but rather the path of the Earth around the sun is elliptical. Okay, so we are going to start with the Earth's position. See, I can move this. Okay, thanks to our dear friend Amaresh GS. Okay, so he has created this. By the way, while I am at that point, let me also mention something else. Well, as many of you are going through this course, many have sent me requests like, can I share this demonstration tool with them? There is nothing secretive about this. And in principle, there should be no reason why I would not share this tool with those people who are participating in the course. However, the answer is no. And the reason I am not going to share the tool, at least at this stage, is because this is the first time we are using these tools. There are some errors that pop up that we realize as we make use of them, as I make use of them. And between myself and Amaresh, we are going back and forth and trying to fine tune these demonstration simulators. In addition, while demonstration simulators do a decent job of demonstrating certain aspects that must be studied in this course, sometimes the very nature of astronomy introduces some errors. Let's begin from the point of the vernal equinox. So Earth is at the point of vernal equinox. Now notice what happens. Some of the previous modules, I was showing the Earth at the center and the sun was at the point of vernal equinox. And so when I showed Earth here, sun here, and if we can extend the line, then the nakshatra of the vernal equinox was actually shown as Uttara Bhadrapada. Now remember, we have switched the positions. The sun is at the center, Earth is in the circle outside. So if you want to know the position of the sun on the day of vernal equinox, what we need to do is that the position of the Earth is at the vernal equinox, but to know the position of the sun, we have to draw the imaginary line that goes through the sun, and it's extended against the background nakshatra system, and the nakshatra would appear to be close to Uttara Bhadrapada, right? So let's call it Uttara Bhadrapada. All right, so now what would happen? The Earth is going to start traveling from there. Okay, so the first month of Vasanta Rutu, spring season, would be over. Then it would enter the Grishma season or the summer season, then the first month of summer season, then the second month of summer season, and at the end of it, it will arrive at the point of summer solstice. If you want to know the nakshatra of the sun when the Earth is at the summer solstice, what we need to do, remember, in this demonstration simulator, sun is at the center. So we draw a line from the sun. It goes all the way through to the other side of the nakshatra system, and we will find that the nakshatra of the sun around the time of summer solstice is Mrugashirsha, Ardra, somewhere here. Okay, now we will just continue to go through this. Okay, we will enter the Varsha season of 2 months. Then we will enter the Sharat season or the pre-autumn season. We will get to the point of the autumnal equinox or the fall equinox. If you want to know the nakshatra of the sun, what we would do is we will draw a imaginary line through the sun to the other side and note down the nakshatra. Then we continue and it's the end of the Sharat season. Then we enter the Hemanta season. And after 2 months, we are at the point of winter solstice. We can note down the nakshatra of the sun by drawing that imaginary line and looking at the background reference system. We will find out at the winter solstice, the nakshatra of the sun is around Mula. All right, and let's complete this. Then we go into the Shishira season of 2 months. Then we enter the Vasanta Rutu or a spring season, and we arrive back at the point of vernal equinox for the next year, and new solar year begins from this point. Okay, now that's a typical circle that you are used to. The two important points with respect to this sun and the earth system I want to show you are these aphelion and perihelion. We discussed these points, but now we are going to discuss those points with respect to the background nakshatra system. So as the earth goes around the sun, and let's say it comes to the point of this aphelion, what does that mean? Remember, A in aphelion or apogee is away, farthest. It is away from the sun. Now notice what is happening here. The F2 is that second focus or second foci, you can say plural, and sun is on the other side. So sun is, so this point here where earth is right now at the aphelion is the farthest point from the sun during earth's orbiting around the sun. Okay, so now what would happen if you think of seeing it from the sun? It would appear as if the earth is, because it's farthest, is going, it appears as if it's going into this angular journey at the slowest. Of course, we are not interested in a calendar on the sun, so we are going to look at it from the earth's point of view. So as seen from the earth, when the earth is at the point of aphelion, it's going to perceive the motion of the sun, the angular motion of the sun. Remember, it's going to appear as if like sun is going around the earth, although in reality earth is going around the sun. We did show that simulation before. So as seen from the earth at the point of aphelion, the sun would appear to travel the slowest in its angular path, and that is the mandocha, okay, the slowest point. On the other hand, if we bring the position of the earth as it goes around the sun to the point of perihelion, now the sun is closest to the earth, okay, just net distance. And as seen from the earth, the sun would appear, going around the earth, of course, sun would appear to go fastest, okay, among at any other point. This it would appear to be the fastest. Now let us note down where are these positions. For example, the position, this is, we are talking for our times, 21st century. The position of the sun when earth is at aphelion, which is farthest from the sun, is around Nakshatra Ardra Punarvasu. Okay, so here. So to note down the position of the sun at the point of aphelion, which is to say farthest from the earth, is when sun is in the nakshatra Ardra Punarvasu, of course, as seen from the earth. Now, when does this appear? This occurs around, in our times, around the 4th of July, 3rd, 4th of July, somewhere. Think of this as the first week of July. So summer solstice is on the 21st June, and then another 15 days are gone by and somewhere there. Okay. On the other hand, if you want to note down the position of perihelion, which is where a sun appears to travel faster as seen from the Earth, that position occurs sometime after the day of winter solstice, which is 21st December. Okay, remember, at the perihelion, the sun appears to travel fastest because it's closest to the Earth. In the angular momentum, when I say appear, actually it does travel fast. Okay, and when the Earth is at aphelion, or you can say the sun is at aphelion, it doesn't matter, which is like the farthest distance between the two, the sun appears to travel the slowest, mandocha. Actually, as far as the angular distance is concerned, it does travel slow. Okay, and again, I would say, if you understand it, why that happens because of the distance and the ellipse, great. If not, you must take it on Shraddha until you put your own efforts through Wikipedia, Google, YouTube to catch up with what is being covered in the class. Now, without actually showing the position of the moon at the perigee or apogee, I'm going to say that the same thing happens for the motion or the movement of the moon as seen from the Earth as moon goes around the Earth. So sometimes the moon will appear to go faster, okay, and sometimes it will appear to go the slower, and then the slowest and the fastest. Again, at the point of perigee, okay, it will appear to go fastest. At the point of apogee, it will appear to go the slowest. Now remember, moon is much more dynamic body. Okay, it's making like close to 12 rotations in one solar year when sun is only making one rotation. Moon is easily affected by the gravity of other objects. Moon also has its node. Okay, I mean, so does the sun, but the moon also has its node. You know, it cuts the ecliptic like twice in a given month. So there's a lot more that is happening with respect to the movement of the moon as seen from the Earth. In fact, that's why all the astronomers, especially those who were making revolutionary discoveries with respect to astronomy, both in the Indian context, but even in the Western European context in last 500, 600 years, they were always challenged by this movement or the motion problem of the moon. So important point here to note is that we understood that Adhika Tithi happens and what exactly that means. Adhika Nakshatra occurs and what that means. Kshaya Tithi and Kshaya Nakshatra happens, what does that mean? Of course, we understand why we need to insert a intercalary lunar month or Adhika masa, and that is, of course, to synchronize the solar year of 365 65 days approximately with the lunar year of approximately 354 days. It leaves a gap of about 10 to 11 days, and it needs to be compensated so that the daily lunar calendar stays in sync with the solar calendar, which defines the seasons. So we will look into the Adhika Masa, but the takeaway here is that Adhika Tithi, Adhika Nakshatra, Kshaya Tithi, Kshaya Masa, they do occur. That has to do with the fact the orbits are elliptical, the orbit of the Earth around the sun, the orbit of the moon around the Earth,